All right, welcome to section 7.1. We are now starting our geometry unit. You'll notice today's title section is dilations. And we're going to, in just a minute, I'm going to ask you to go watch this video. You'll just need to type in that. Or if you go to YouTube and you search dilations, this one will come up as well, and you can watch that. It gives a great, two great examples of what dilations are and their properties. And so if you'll listen to that first before we fill out the notes, then that will help you as we finish filling out our 3 examples that we're going to do today, or 4 examples that we're going to do today. So first, what is a dilation? You can find the definition of a dilation on page 196 of your workbook, and also some examples of it. On page 196, this is page 196 in our vocabulary box, we have what a dilation is. It says a dilation is a transformation that produces an image that is the same shape as the original figure, but it will be a different size. Now last year in secondary 1, you did transformations, you did transformations, you did translations, reflections, and rotations. And now this year we're doing one more type of transformation, and that's called a dilation. In the previous year, reflections, rotations, and translations kept their congruency, so the shape looked exactly the same with the same size and shape. But now it will have the same shape, but it will not be the same size. The dilation will use a center and a scale factor to create what's considered a proportional figure. And we'll be dealing with proportionality and similarity as we go throughout this unit. What is the center of dilation? Well, the center of dilation is just a fixed point in the plane about which all the other points are expanded or contracted. And you decide how it's going to be expanded or contracted by the scale factor. The scale factor is the ratio of the new image to the original image. So for instance, if the original image had a length of 2 and the new figure had a length of 4, then its scale factor would be 4 over 2, or in other words, it would get double, it would increase or be 2 times its size. So again, it will still look the same kind of shape, but it will be a different size. And you can kind of see that idea right here when we go from B to B prime. So now this time I'd ask you to go ahead and watch that video on YouTube, and then come back and follow along on the notes. So example 1 asks us to dilate a triangle with vertices 1, 1, 4, 1, and 4, 4. So just like they did on the video, I'm going to go ahead and get those points plotted. So this is my A, B is at 4, 1, and C is at 4, 4. And I'm going to label those my A, B, and C and connect them. Remember last year we called that our pre-image, and now we're going to do a dilation. It's going to have a scale factor of 3 and be centered at the origin. So my point of dilation will be right here at the origin, and this is the easiest type of dilation to do. Now, as they did on the video, if it's centered at the origin, then you simply need to take your scale factor, which in this case is 3, and multiply all of your ordered pairs by 3. So A prime will be, if it was 1, 1, then timesing it by 3 will make it 3, 3. B prime timesing it by 3 will make it 12, 3. And C prime, multiplying it by 3, will make it 12, 12. So now I'm just going to take and plot those 3 points, and that will be my dilation. So 3, 3 will be right here. So this is my A prime. 12, 3. This will be my B prime. And C prime will be 12, 12. So that's my new image being dilated by a scale factor of 3. Now the video makes it really nice in that then they show how between A and A prime, if you connect those, that should go to the dilation, point of dilation, as well as C and C prime. You can kind of see they lie on all the same line. And then if I look at B and B prime, you just use a straight edge here so you can see here's my point of dilation, and if I line up B and B prime, sure enough, they also work there. We also in the video talked about how you have a ratio that this length and this length have a proportion that this is twice as long as this one. This length is, or 3 times, excuse me, 3 times as long as this one. This is 3 times as long as this one. This one's 3 times as long as this one. This is 3 times as long as this one. I think I said that wrong the first time. Okay, so if you want, you can turn off the video and try B by yourself and then compare, or you can go ahead and work with me. This time we're going to have a parallelogram, and it's going to be at negative 4, 4 for A. That's my pre-image. B is at 6, 6. C is at 6, negative 2. And D is at negative 4, negative 4. Again, I'm going to connect my points. Use a straight edge just so I get a little bit better shape. This time they want me to do a scale factor of a half. So now instead of my figure enlarging, it's actually going to reduce inside. The point of origin is still here at 0, 0. That's my point of, my point of dilation is at 0, 0. So as we did on example A, because it's at 0, 0, I'm just simply going to do half of each of them. So my A prime will be negative 2, 2. My B prime, half of 6 and 6 is 3, 3. My C prime, half of 6 is 3, and half of negative 2 is negative 1. And my D prime is at negative 2, negative 2, because I'm just dividing both of those by 2. And again, I'm just going to go plot those. I'm just using a different color so that you can see the difference between them. So, this down just a little bit. Negative 2 and 2 be right here. That's now my A prime. B will be at 3, 3. That's my B prime. C is at 3, negative 1. And D is at negative 2, negative 2. That's my D prime. And again, I can see that my shape has reduced in size because it had a scale factor of 1/2. And again, I can see my point of dilation. If I go from A to A prime, it comes through the point of center of dilation. There it is right here, here, and here. I can see that my picture is accurately drawn with my point, my center of dilation being at the origin. So again, I could kind of connect. Here's my A, here's my C's, here's my B's and D's. Okay, that's if it is centered at the origin. That's the easiest type, in my opinion, to do. So now let's do the second type. Now in the video they didn't do one like this, although they did reference it. On this particular case, the center of dilation is going to be on the shape, on what be one of the vertices. So first let's get our square done. Draw on our original square. So it's at negative 1, 1. That's my A. B is at negative 4, 1. C is at negative 4, 4. And D is at negative 1, 4. And they want a scale factor of 2, but this time it is centered at negative 4, 4. So here's negative 4, 4, which happens to be C. So that means that that's also C prime, that it will be the same distance as well, and my center of dilation is right there as well. So if that's my center of dilation, I can either I can do any of them. I'm going to choose to do D first. So when I look at my point of dilation to get it, my center of dilation, to get to D, it would be 1, 2, 3. And if it's a scale factor of 2, that means I need to, instead of 3 long, it needs to be 3 times 2, which is 6. So this needs to go a total of 6 from the center of dilation. So 1, 2, 3, 4, 5, 6. So D prime will be right here. Another way you can think of it as well is that this was 3, and you're going to double it, so you're going to go 3 more. I'm going to go hit B next. It's 3 down, so doubling it will be 6 down. Or here's 3, and then do 3 more. So here's B prime. And then for A, a couple of different ways you can think about it. I can say, well, from B to A, it's 3. That distance is 3. So now, with a scale factor of 2, it needs to be 3 times 2, so 6. We should put it right here. Or you could go from the point of dilation and say, well, to get to A, I had to go right 3 and down 3. So that means that I need to go right 6 and down 6. Or from point A, go right 3 and down 3 more, and you still end up right there at A prime. You connect your dots. And again, you can see your center of dilation, that all points should lead back to that center of dilation. So D prime and D lead to the point of dilation. B prime and B lead to the point of dilation. A prime and A lead to the point of dilation. Then the last thing you need to do is just state your new coordinates for A prime, B prime, C prime, and D prime. So you'll just do those ordered pairs. So starting with A, looks like it's at 2 and negative 2. Oops. Did I go down too far? Hang on. 1, 2, 3, 4. Oh, I did. 6 should be right here. Because there's 1, 2, 3, 4, 5, 6. Dang it. B prime and A prime. So A is at 2, negative 2. Sorry for making that mistake. Cannot count squares this afternoon. B prime is at negative 4 and negative 2. C prime is still where it was at C, which is negative 4, 4. And D prime is at 2, 4. It wouldn't be a normal video if I didn't make at least one mistake. Okay, we're going to save C down here just for your information for our warm-up tomorrow. Be the warm-up. And we're going to change the scale factor tomorrow. You'll just have to wait to see what we're going to change the scale factor so that it will fit on our graph. All right, we're going to dilate the triangle on B with vertices negative 1, 1. Try it one last time and we'll be done. 4, negative 4, negative 4, positive 4. Negative 4 and positive 4. And 5, negative 1. So again, make sure I graphed it right since no one's here to tell me if I make a mistake. Negative 4 and 1, 2, 3, 4. And negative 5 and 1. Again, I need to label them. This is my A, B, and C. My point of dilation, again, is at one of the points on the shape already. It's at negative 1, 1. So it's right here. And that's my A prime. And it has a scale factor of 2. So A and A prime will stay. For C, it's 1, 2, 3, 4. So I need to go 4 more. 1, 2, 3, 4 to double it. Or 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is my C prime. Now to get to B, you have to use the idea that was talked in the video and that we tried to talk about when we did A. To go from the point of dilation to B, it's up 1, 2, 3, and over to the left, 1, 2, 3. So this is up 3 and over 3. So if I'm going to double it, it will go up double that. So 3 times 2 is 6. So 1, 2, 3, 4, 5, 6, and over 6. 1, 2, 3, 4, 5, 6. And that will be my new B prime. Or from this point, you could just do the same move as you did here because you're going to do it twice. 1, 2, 3, and 1, 2, 3. Had this been a scale factor of 3, then I would have done it. Here's my first time, and then I would do 1 more for 2 times, and then 1 more for 3 times. Or you can just times by 3, however you want to do it. Now that I've got my A prime, my B prime, and my C prime, I'm just ready to connect my dots. Connect my vertices. And again, we can see that all points from B prime to B to the point of dilation should lead back to the center of dilation. These lead back to the center of dilation, and then A is itself. All right, so that's what dilations look like. Again, notice how the shapes are similar. They both look like triangles with the same type of slope, but the lengths are going to be double in size. This length here is half as long as this one, or the length from A prime to B prime is double the length from A to B. And those will all be proof kinds of things that we will do later in the unit. All right, enjoy your assignment.